Hello. In this video and the next couple of videos, our main focus will be on Cramer rules. So in order to explain Cramer's rule, we need to find the inverse of a matrix, inverse of a 2 by 2 and 3 by 3 matrix. So for that, we need the adjoint of the matrix. So in this video, we will explain what is adjoint of a matrix. So let us assume a general 3 by 3 matrix whose entries are very general. Then first we define the ijth cofactor. So the ijth cofactor of A, which is usually denoted by aij, is defined as minus 1 to the power I plus j. I mean, the ijth cofactor equals minus 1 to the power I plus j times the determinant of the submatrix, which is obtained by deleting ith row and jth column. I mean, I will write the determinant of a matrix, for example, Cij, where Cij is a matrix obtained by deleting ith row and jth column. So Aij is obtained by deleting ith row and jth column of A. For example, if you have this matrix and you want to find its cofactors, here we can find many cofactors because I told you that we can find ijth cofactor. Here I can find 1 cofactor, 1 2 cofactor, 1 3. Here for this element is a cofactor is 1 1. For this element the cofactor is 1 2. For this element 1 3. So for each entry we can find a cofactor, right? And so on. So let's find, for example, a1 2. Okay, so by definition the cofactor aij is negative 1 to the power I plus j. So I will write negative 1 to the power 1 plus 2 times the determinant of a matrix obtained by the first row, deleting the first row and the second column. Delete the first row and second column, you will get 3 minus 1 0 0. If you do that, minus 1 to the power 3, which is minus 1 to the power odd number, and minus 1 to the power odd number is always minus. And what is this determinant? This determinant is only the product of these two minus the product of these two. Since the product of these two is 0, minus the product of these two is also 0, so the answer is 0. Similarly, you can find any other cofactor. For example, if you want to find the cofactor based on this element, and this element is in the second row and the third column, so that means I need to find A23. If I have to find A23, what will I do? I will write minus 1 to the power 2 plus 3 first. And then I will write the determinant of a submatrix obtained by deleting the second row and the third column. If I delete the second row and the third column of a matrix, I will end up with 1, 2, and 0, 1. So I will write 1, 2, and 0, 1. If I simplify this thing, minus 1 to the power 2 plus 3, which is minus 1 to the power 5. Since minus 1 to the power 5 is odd number, so minus 1 to the power odd number is always minus. So the determinant of this is just the product of these two, which is 1, minus the product of these two, which is 0. If I simplify, it will give me minus 1. So in this way, I can find the cofactor of any given matrix. So once we understand how to find the adjoint, how to find the cofactors, then we can define the adjoint of a matrix. So, for example, you are given a matrix A. Usually we will take 3 by 3 matrix. So if you are given a 3 by 3 matrix, then the adjoint of A can be defined as a matrix in which we will write all of the cofactors. So the first row will be A11, A12, A13. I mean, this is for the cofactors, it's not for the general elements. Second row will be A21, A22, A23, and the last row is this one. So adjoint of a matrix A is a matrix obtained by entering the cofactors of a matrix, but at the end you will take the transpose of the matrix, then you will get the adjoint. So adjoint is the transpose of cofactors. Okay, once we define the adjoint of a matrix, let's do an example. Suppose you have a matrix, then we have to find its adjoint. In order to find the adjoint, we need to find all of the cofactors starting from A11. Since A11 is negative 1 to the power 1 plus 1 times a matrix obtained by just deleting this row and this column, you will get this thing, which is equal to just, since negative 1 to the power 1 plus 1 is plus 1, so plus 1 times the determinant. Okay, the determinant is obtained by multiplying 2 with 4, which is 8, and minus 0. Okay, if I simplify it, I will get 8. Then I will find A12. A12 is negative 1 to the power 1 plus 2 times the determinant obtained by deleting this and this. I will get negative 5, negative 1, 3, 4. Okay, since minus 1 to the power 1 plus 2 is negative, because it's minus 1 to the power odd number, minus 1 to the power odd number is negative, times the determinant of this matrix, which is just the product of these two, which is negative 20, minus the product of these two. Okay, so minus 3 times minus 1. If I simplify, I will get negative times negative 20 minus 3 times minus 1 is plus 3. If I simplify these two things, I will get minus 17. So it is plus 17. Okay. Then if we look at A13, A13 is negative 1 to the power 1 plus 3 times. So one row and first row and third column I will delete. Then I will get this thing. So that means I will get this matrix. If I simplify these values, minus 1 to the power 1 plus 3 is 4, which is even number. I will get plus. So if I evaluate this whole determinant, minus 1 to the power 1 plus 3 is 4, which is minus 1 to the power even number, which is plus 1, times the product of these two, because the determinant is just the product of these two minus the product of these two. Product of these two is 0, because minus 5 times 0 is 0, minus the product of these two, which is negative 6. So my answer is negative 6. So if I wish to find A21, my answer will be minus 1 to the power 2 plus 1 times the determinant of the submatrix obtained by deleting second row and first column. I will get 0, 2, and 0, 4. 0, 2, and 0, 4. Since minus 1 to the power 3 is odd number, I will write minus. Then the determinant of this is the product of these two, which is 0, minus the product of these two, which is again 0. So I will end up with 0. Then A22 is just minus 1 to the power 2 plus 2 times the determinant obtained by deleting second row and second column, I will get 1, 2, 3, 4. So I will just write 1, 2, 3, 4. And then minus 1 to the power 4. 4 is even number. So I will write plus. The determinant of this is just the product of these two, which is 4, minus the product of these two, which is 6. I will end up with negative 2. Then A23 is just negative 1 to the power 2 plus 3 times the determinant of the submatrix obtained by deleting second row and the third column of the matrix. So if I delete the second row and the third column of the matrix, I will get 1, 0 and 3, 0. So I will write 1, 0 and 3, 0. If I simplify this value, minus 1 to the power 5 is odd number, so I will write minus, times the determinant of this matrix is just the product of these two, which is 0, minus the product of these two, which is again 0. If I simplify this, I will get 0. Now, I have the cofactor 3, 1, which is just minus 1 to the power 3 plus 1 times the determinant of the submatrix obtained by deleting the third row and the first column of the matrix, which is just this matrix. This matrix is 0, 2 and 2, minus 1. If I simplify this, minus 1 to the power, this is 4. So minus 1 to the power even number is plus 1 times the determinant of this matrix, which is the product of these two, which is 0, minus the product of these two, which is 4. If I simplify, I will get negative 4. Then I have A32, which is just negative 1 to the power 3 plus 2 times the determinant of the matrix obtained by just deleting the third row and the second column, which is 1, 2, minus 5, minus 1. If I simplify this value, since minus 1 to the power 3 plus 2 is 5, which is odd number, so I will write minus, times the determinant of this, which is obtained by multiplying these two values. If I multiply 1 with minus 1, I will get minus 1, minus the product of these two. If I multiply minus 5 with 2, I will get minus 10. Okay, if I simplify these things, this minus stays as it is. This minus 1 stays as it is. This minus will kill this minus. It will become plus 10. And minus 1 plus 10 is 9. So I will end up with minus 9. The last cofactor is A33, which is just minus 1 to the power 3 plus 3 times the determinant of the submatrix, which is obtained by deleting the last row and the last column, which is just 1, 0, minus 5, 2. If I simplify these values, which is minus 1 to the power 3 plus 3, which is minus 1 to the power 6, which is even numbers, so I will have plus, times the determinant of this matrix, which is obtained by multiplying these two elements, which is 2, minus the product of these two, which is 0. So the result is 2. Now I have all of the cofactors. Now if we again visit the definition of the adjoint of a matrix, the adjoint of a matrix is obtained by entering the cofactors inside the matrix and taking the transpose. Okay, so now I will find the adjoint of a matrix A, which is just A11, A12, A13, A21, A22, A23, A31, A32, A33. But the transpose of this matrix, if I add all of these values, because I have already found those values, A11, A12, A13 are 8, 17 and minus 6. So I will write 8, 17 minus 6. Then A21, A22, A23 are 0, minus 2, 0. So I will write 0, minus 2, and then 0. And the last three values are minus 4, minus 9, and 2. So minus 4, minus 9, and 2. But I have to take the transpose because of the definition of the adjoint of the matrix. If I take the transpose of this resultant matrix, this row will become a column, the first column. I will write 8, 17 minus 6. And this row will become the second column, which is 0, minus 2, 0. And the last row will become the last column, which is minus 4, minus 9, and 2. So this is the complete solution of the adjoint of a matrix. In this way, you can find the adjoint of any matrix. The main theory, the main important thing is that how you can find the cofactors of a matrix. If you are able to find the cofactors of a matrix, then you will just put the cofactors inside and just take the transpose. And the result which you will get will be the adjoint of the matrix.